Dear students, I am Dr. Ritu Sharma. I am an assistant professor at National Law University, Delhi. Today we are going to discuss an important module from research methodology, hypothesis. While discussing the module, we will be talking about the meaning and definition of hypothesis, the nature of hypothesis, the importance and use of hypothesis in research methodology. We will also look into the sources of hypothesis, the relationship between variables and hypothesis, the types of hypothesis, and ending the presentation with characteristics of a good hypothesis, hypothesis testing and errors in hypothesis testing. So, while we discuss what is hypothesis, we should start with the meaning of it. Hypothesis is usually considered as an important mechanism in research. Hypothesis is a tentative assumption made in order to test its logic or empirical consequences. If we go by the origin of the word, it is derived from the Greek word hypotythenia, meaning to put under or to suppose. Etymologically, hypothesis is made up of two words, hypo and thesis, which means less than or less certain than a thesis. It is presumptive statement of a proposition or a reasonable guess based upon the available evidence which the researcher seeks to prove through his study. A hypothesis will give a plausible explanation that will be tested. A hypothesis may seem contrary to the real situation. It may prove to be correct or incorrect. Hypothesis is needed to be clear and precise and capable of being tested. It is to be limited in scope and consistent with known or established fact and should be amenable to testing within the stipulated time. It needs to explain what it claims to explain and should have empirical reference. Goodey and Hart have defined it as a proposition which can be put to test to determine its validity. And Lundberg says a hypothesis is a tentative generalization, the validity of which remains to be tested. In most elementary stage, the hypothesis may be any hunch, guess, imaginative idea which becomes the basis for action or investigation. Hence, a hypothesis is a hunch, assumption, suspicion, assertion or an idea about a phenomenon, relationship or situation, the reality of or truth of which you do not know. So, a researcher calls these assumptions or hunches hypotheses and they become the basis of an inquiry. In most studies, the hypothesis will be based upon your own or someone else's observation. Hypothesis brings clarity and specificity to a research problem, but it is not essential for all kinds of research. So, the formulation of hypothesis provides a study with the focus. It also tells you what specific aspect of a research problem to investigate. A hypothesis tells you what data to collect and what not to collect, thereby providing focus to the study. As it provides a focus, the construction of a hypothesis enhances objectivity in a study. A hypothesis may enable you to add to the formulation of a theory. It enables you to specifically conclude what is true or what is false. Lundberg observes, quite often a researcher hypothesis is a predictive statement capable of being tested by scientific method that relates an independent variable to some dependent variable. So, once we know what actually hypothesis mean, we should also understand the nature of hypothesis. The hypothesis is a clear statement of what is intended to be investigated. It should be specified before research is conducted and openly stated in reporting the results. This allows to 1. Identify the research objectives, 2. To identify the key abstract concept involved in the research, 3. To identify its relationship to both the problem statement and the literature review. And a problem cannot be scientifically solved unless it is reduced to hypothesis form. It is a powerful tool of advancement of knowledge consistent with existing knowledge and conducive to further inquiry. It can be tested, verifiable or falsifiable. Hypotheses are not moral or ethical questions. It is neither too specific nor too general. It is a prediction of consequences. It is considered valuable even if proven false. Once we have understood the hypothesis, the nature of hypothesis, why is it so important in research? So, now we are going to discuss the importance of hypothesis. So, hypothesis, though an important part of research, may not be required in all types of research. The research which are based on fact finding like historical or descriptive do not need hypothesis. Hilve says that when act finding alone is the aim of the study, a hypothesis is not required. Whenever possible, a hypothesis is recommended for all major studies to explain observed facts, conditions or behaviors and to serve as a guide in the research process. Hypothesis facilitates the extension of knowledge in an area. They provide tentative explanation of facts and phenomena and can be tested and validated. It sensitizes the investigator to certain aspects of their situation which are relevant from the standpoint of the problem in hand. Hypotheses provide the researcher with rational statement consisting of elements expressed in a logical order or relationship which seeks to describe or to explain conditions or events that have not yet been confirmed by the facts. The hypothesis enable the researcher to relate logically known facts to intelligible guesses about unknown conditions. It is a guide to the thinking process and the process of discovery. Hypotheses provide direction to the research. It defines what is relevant and what is irrelevant. The hypothesis tells the researcher what he needs to do and find out in his studies. Thus, it prevents the review of irrelevant literature and provides a basis for selecting the sample and the research procedures to be studied in the study. Hypothesis implies the statistical techniques needed in the analysis of data and the relationship between the variables to be tested. It also helps to delimit researcher's study in scope so that it does not become broad or unwieldy. Hypothesis provides the basis for reporting the conclusion of the study. It serves as a framework for drawing conclusion. In other words, we can say that it provides the outline for setting conclusion in a meaningful way. So, hypothesis has very important place in research, although it occupies a very small place in the body of a thesis. So, once we are done the importance of hypothesis, we should also be seeing that how we can actually derive hypothesis. A good hypothesis can only be derived from experience and research, though hypothesis should precede the collection of data, but some degree of data collection, literature review or a pilot study will help in the development and gradual refinement of the hypothesis. A researcher should have quality of an alert mind to derive a hypothesis and quality of critical mind of rejecting faulty hypothesis. The following sources can help the researcher in coming up with a good hypothesis. 1. Review of literature. Review of literature is very important in forming a hypothesis because you get an idea of what type of hypothesis you need to achieve your objectives, and discussion with the experts in the given field to understand the problem, its origin and objective in seeking a solution will also help you in forming a very good hypothesis. Intuitions of the researcher also sometimes help in forming a good hypothesis because you always have an idea what you are looking for in your research, and that actually helps you in forming a good hypothesis. Previous empirical studies done on the given area also become a very good source for hypothesis. When you go through the previous researches, that actually gives an idea what you have to look into when you are conducting your own research. Once we know the sources of hypothesis and we have formulated the hypothesis, we should also understand what all types of hypotheses are there in research. So, research problems are too general by themselves to enable us to carry out meaningful analysis. They need to be specified in a more focused way. Hypotheses are specific statements that relate to the problem, the answers to which are likely to be yes or no, depending upon what is uncovered from the research. Like suicide is related to general level of religiosity or secularization of society. Another example could be alienation and political participation are negatively related. Such statements specify links between different phenomena. In order to explain different pattern of behavior that appear to occur, such statements specify links between different phenomena in order to explain different pattern or behavior that appear to occur. However, such pattern or association do not necessarily demonstrate that a causal relationship exists. We cannot, for an instance, say socio-economic deprivation causes suicide. If that was the case, then all those who defined by various yardsticks as living in a state of relative poverty would inevitably commit suicide. This is very unlikely to happen. So, if we have to understand types of hypotheses, we do need to understand what are the variables that actually affect these type of hypotheses. So, to understand the type of hypothesis, we need to understand the concept of variable first. The variables are empirical properties that take two or more values, or in other words, a variable is any entity that can take on different values. It's in simple terms, anything that can vary or that is not constant can be considered a variable. For instance, age can be considered a variable because age can take different values for different people or for the same person at different times. Similarly, country can be considered a variable because person's country can be assigned a value. A variable is a concept or abstract idea that can be described in measurable term. In research, this term refers to the measurable characteristics, qualities, traits or attributes of a particular individual, object or situation being studied. Variables differ in many respects, most notably in the role that they are given in our research and in the type of measure that can be applied to them. The statement of problem usually provides only general direction for the research study. It does not include all the specific information. There is some basic terminology that is extremely important in how we communicate specific information about research problem and research in general. So, weight, height, income, all are examples of variables. In research, there is need to make distinction between various kinds of variables. There are many classifications given for variables. We will try to understand only the dependent variables and the independent variables. Independent variable, the variables which are manipulated or controlled or changed. These are also known as manipulated variables. Researchers often mistake independent variables and assume that it is independent of any manipulation. It is called independent because variable is isolated from any other factor. In research, we try to determine whether there is a cause and effect relationship. In fact, when you are looking for some kind of relationship between variables, you are trying to see if the independent variable causes some kind of change in the other variable or dependent variable. And now we are going to discuss what is dependent variable. Dependent variables are the outcome variables and are the variables for which we calculate statistics. The variables which change on account of independent variables is known as dependent variables. It is something that depends on the other factors. For example, a test score could be dependent variable because it could change depending on the several factors such as how much you studied, how much sleep you got the night before you took the test, or even how hungry you were when you took it. Usually when you are looking for a relationship between the two things, you are trying to find out what makes the dependent variables change the way it does. As we have discussed that a variable is an image, perception or concept that can be measured, hence capable of taking on different values. The variables that you wish to explain are regarded as dependent variables or criterion variables. The other variables expected to explain the change in the dependent variables is referred to as an independent variable or predictor variable. The dependent variable is the expected outcome of the independent variable, and independent variable produces dependent variable. So, variables can have three types of relationship among themselves. A positive relationship is one where an increase in one would lead to increase in the other. For example, more you study, higher your score would be. A negative relationship is one where an increase in one variable leads to decrease in the other. More you watch TV, less marks you are going to get. A zero relationship is one which shows no significant relationship between the two variables. For example, having any kind of food will not fetch you marks. These are the type of relationship which variables have. So, once we have understood variables, we can discuss the various types of hypothesis. The first one is the research hypothesis. The research hypothesis could be understood in terms of simple research hypothesis and complex research hypothesis. A simple research hypothesis predicts the relationship between a single independent variable and a single dependent variable, whereas a complex hypothesis predicts the relationship between two or more independent variable and two or more dependent variable. A research hypothesis must be stated in a testable form for its proper evaluation, and it should indicate a relationship between variables in clear, concise and understandable language. Research hypotheses are classified as being directional or non-directional. A directional hypothesis are usually derived from theory. They may imply that the researcher is intellectually committed to a particular outcome. They specify the expected direction of the relationship between variables. That is, the researcher predicts not only the existence of a relationship, but also its nature. Non-directional hypotheses on the other hand are used when there is a little or no theory, or when findings of previous studies are contradictory. They may imply impartiality, do not stipulate the direction of the relationship. Another types of associations are associative hypothesis and causal hypothesis. Associative hypothesis propose relationship between variables. When one variable changes, the other changes. They do not indicate cause and effect. Whereas the causal hypothesis propose a cause and effect interaction between two or more variables. The independent variable is manipulated to cause effect on the dependent variables. Then there is a statistical hypothesis. To test whether the data support or refute the research hypothesis, it needs to be translated into a statistical hypothesis. It is given in statistical terms. In the context of inferential statistics, it is statement about one or more parameters that are measures of the population under study. Now we need to understand what is this inferential statistics. Inferential statistics is used for drawing conclusion about population values. To use inferential statistics, we need to translate the research hypothesis into a testable form, which is called the null hypothesis. A testable hypothesis contains variables that are measurable or able to be manipulated. They need to predict a relationship that can be supported or not supported based on the data collection and analysis. So now we come to a very important types of hypothesis, which is called as null hypothesis and alternative hypothesis. Null hypotheses are used when the researcher believes that there is no relationship between two variables, or when there is inadequate theoretical or empirical information to state a research hypothesis. The null hypothesis represents a theory that has been put forward either because it is believed to be true or because it is to be used as a basis for argument, but has not been proved. This has serious outcome if incorrect decision is made, and null hypothesis is designated by either HO or HN. Null hypothesis can be simple or complex, or associative or causal, which we have already seen. The alternative hypothesis is a statement of what a hypothesis test is set up to establish. It is designated by H1 or HA. It is opposite of null hypothesis. It is only reached if HO is rejected. Frequently, alternative is actual desired conclusion of the researcher. We give special consideration to the null hypothesis. This is due to the fact that the null hypothesis relates to the statement being tested, whereas the alternative hypothesis relates to the statement to be accepted if when the null hypothesis is rejected. The final conclusion, once the test has been carried out, is always given in terms of the null hypothesis. We either reject null hypothesis in favor of the alternative hypothesis or do not reject null hypothesis. We never conclude reject alternative hypothesis or even accept alternative hypothesis. If we conclude do not reject null hypothesis, this does not necessarily mean that the null hypothesis is true. It only suggests that there is not sufficient evidence against null hypothesis in favor of alternative hypothesis. Rejecting the null hypothesis then suggests that the alternative hypothesis may be true. For example, alternative hypothesis is the males visited cinema more than females, and the null hypothesis is the males and females do not differ in respect of the frequency of seeing cinema. So, alternative hypothesis is usually the one which one wishes to prove, and the null hypothesis is the one which one wishes to disapprove. And now, once we are done with the types of hypothesis, let us understand how hypothesis is formulated, because that is the most important concept in research. There are no precise rules for formulating hypothesis and deducing consequences, but there are some difficulties that arise in formulating the hypothesis. However, there are certain necessary conditions that are conducive to the formation. They are, for example, richness of background knowledge. In the absence of knowledge concerning a subject matter, one can make no well-founded judgment of relevant hypothesis. Background knowledge is essential for perceiving relationship among the variables and to determine what finding other researchers have reported on the problem under study. New knowledge, new discoveries and new inventions should always form continuity with the already existing corpus of knowledge, and therefore it becomes all the more essential to be well versed with the already existing knowledge. Hypothesis can be formulated correctly by person who have rich experience and academic background, but they can never be formulated by those who have poor background knowledge. There is another point which is very important in formulating hypothesis: logical and scientific approach. Formulation of proper hypothesis depends on one's experience and logical insights. Hypothesis does not have a clear cut and definite theoretical background. Partly it is a matter of lifting upon an idea on some problem, and it is not always possible to have complete information of and acquaintance with the scientific method for formulating hypothesis. This lack of scientific knowledge presents difficulty in formulation of hypothesis. A researcher may begin a study by selecting one of the theories in his own areas of interest and deduce a hypothesis from this theory through logic, which is possible only when the researcher has a proper understanding of the scientific methods and has a versatile intellect. At times, conversations and consultations with colleagues and experts from different fields are also helpful in formulating important and useful hypotheses. And now, once we know how to formulate a hypothesis, there are few things that need to be kept in mind in forming a hypothesis, and that they are called as the characteristics of good hypothesis. Hulle says a good hypothesis must be based on a good research question. It should be simple, specific and stated in advance. So, a hypothesis could be called as a good hypothesis if it possesses the following characteristics. 1. Hypothesis should be simple so that it is easily understood by everyone. 2. Hypothesis should be clear, specific and precise. If the hypothesis is not clear and precise, the inference drawn on its basis cannot be taken as reliable. Hypothesis should be capable of being tested. Hypothesis should state relationship between variables. Hypothesis should be consistent with most known facts, that is, it must be consistent with the substantial body of essential facts. The hypothesis must explain the facts that gave rise to the need for explanation. It must actually explain what it claims to explain, and if we keep these points in mind, we are going to formulate a very good hypothesis. So, a very important thing, when we are forming a hypothesis, we should also know how to test a hypothesis. When the purpose of the research is to test a research hypothesis, it is termed as hypothesis testing research. It can be of experimental design or non-experimental design. Research in which the independent variable is manipulated is termed as experimental hypothesis testing research, and a research in which an independent variable is not manipulated is called as non-experimental hypothesis testing research. As we have discussed the null hypothesis and alternative hypothesis earlier, so while testing the hypothesis, we generally proceed on the basis of null hypothesis, keeping the alternative hypothesis in view. We do so because on the assumption that null hypothesis is true, one can assign the probabilities to different possible sample results, but this cannot be done if we proceed with the alternative hypothesis. Hence, the use of null hypothesis is quite frequent. While testing the hypothesis, the following things have to be kept in mind. First, the level of significance. This is a very important concept in the context of hypothesis testing. It is always some percentage, usually 5%, which should be chosen with great care, thought and reason. In case we take the significance level at 5%, then this implies that null hypothesis will be rejected when the sampling result has a less than 0.05 probability of occurring. In other words, this 5% level of significance means that researcher is willing to take as much as a 5% risk of rejecting the null hypothesis when it happens to be true. Thus, the significance level is the maximum value of the probability of rejecting null hypothesis when it is true, and is usually determined in advance before testing the hypothesis. The criteria for rejecting the null hypothesis may differ. Sometimes the null hypothesis is rejected only when the quantity of the outcome is so large that the probability of its having occurred by mere chance is 1 times out of 100. We consider the probability of its having occurred by chance to be too little, and we reject the chance theory of the null hypothesis and take the occurrence to be due to genuine tendency. On the other occasions, we may reject the null hypothesis even when the quantity of the reported outcome is likely to occur by chance 5 times out of 100. Statistically, the former is known as the rejection of null hypothesis at 0.1 level and the latter is known as the rejection at 0.5 level. It may be pointed out that if the researcher is able to reject the null hypothesis, he cannot directly uphold the declarative hypothesis. If an outcome is not held to be due to chance, it does not mean that it is due to the very cause and effect relationship asserted in the particular declarative statement. It may be due to something else which the researcher may have failed to control. Declaration of rule or test of hypothesis is another point we need to keep in mind. Given a null hypothesis and alternative hypothesis, we make a rule which is known as decisive rule, according to which we accept null hypothesis or reject null hypothesis. For instance, if null hypothesis is that a certain lot is good, then there are very few defective items in it, against alternative hypothesis that the lot is not good, where there are too many defective items in it. Then we must decide the number of items to be tested and the criteria for accepting or rejecting the hypothesis. We might test 10 times in the lot and plan a decision saying that if there are none or only one defective items among the 10, we will accept null hypothesis, otherwise we will reject null hypothesis and accept the alternate hypothesis. This sort of basis is known as decision rule. When we are discussing the testing of hypothesis, the important thing that needs to be discussed is the two-tailed and one-tailed tests. In the context of hypothesis testing, these two terms are quite important and must be clearly understood. A two-tailed test rejects the null hypothesis if, say, the sample mean is significantly higher or lower than the hypothesized value of the mean of the population. Such a test is appropriate when the null hypothesis is some specified value and the alternative hypothesis is a value not equal to the specified value of null hypothesis. In a two-tailed test, there are two rejection regions, one on each tail of the curve, which can be illustrated as: if the significant level is 5% and the two-tailed test is to be applied, the probability of the rejection area will be 0.005, equally divided on both tails of the curve is 0.0025, and that of the acceptance region will be 0.95. But there are situations when only one tail test is considered appropriate. A one tail test would be used when we are to test, say, whether the population mean is either lower than or higher than some hypothesized value. We should always remember that accepting null hypothesis on the basis of sample information does not constitute the proof that null hypothesis is true. We only mean that there is no statistical evidence to reject it. And finally, we come to the last part of it, which is the errors in testing the hypothesis. There are basically two types of errors we make in the context of testing of hypothesis. These are called as type 1 error and type 2 error. In type 1 error, we may reject null hypothesis when null hypothesis is true. In type 2 error, when we accept null hypothesis when the null hypothesis is not true. In other words, type 1 error means rejection of hypothesis which should have been accepted, and type 2 error means accepting the hypothesis which should have been rejected. Type 1 error is denoted by alpha, known as alpha error, also called the level of significance of test, and type 2 error is denoted by beta, known as beta error. The probability of type 1 error is usually determined in advance and is understood as the level of significance of testing the hypothesis. If type 1 error is fixed at 5%, it means that there are about 5 chances in 100 that we will reject null hypothesis when null hypothesis is true. We cannot control type 1 error just by fixing at a lower level. For instance, if we fix it at a 1%, we will say that the maximum probability of committing type 1 error would be 0.01. But with the fixed sample size, when we try to reduce type 1 error, the probability of committing type 2 error increases. Both types of error cannot be reduced simultaneously. There is trade-off between two types of error, which means that the probability of making one type error can only be reduced if we are willing to increase the probability of making the other type of error. One must set a very high level of type 1 error in one's testing technique of a given hypothesis. Hence, in the testing of hypothesis, one must make all possible efforts to strike an adequate balance between type 1 and type 2 errors. And this brings to our conclusion of the module. And in this module, what we have done is we have discussed the definition and types of hypothesis. We have also seen the testing of hypothesis, the errors that are there in hypothesis, how do we formulate a good hypothesis, and what are the characteristics of good hypothesis. I hope this module will be of a great help to you. Thank you.